Fajan'S rule. This rule explains the covalent character in ionic compounds. Okay, covalent character in ionic compound. Okay, so in ionic compound, the constituent particles are cation and anion. Okay, cation can be represented like this and anion will be like this. Okay, so when oppositely charged ions, this cation and anion will approach each other, there will be attraction between the positive charge and the negative charge of the anion. Okay, positive charge of the cation and negative charge of the anion. At the same time, there will be repulsion between their two nuclei. Okay, as a result of this, there is a distortion or polarization of the ions takes place. Okay, polarization of ions takes place. When they approach each other, there will be attraction between the positive and negative ions, and also there will be repulsion between the two nuclei. So, polarization of ions takes place. Okay, due to this polarization, there will be high degree of electron cloud is developed between the two ions. We can represent this like this. Okay, positive and negative. A high degree of electron cloud is developed in between the positive cation and negative anion. Okay, and as a result, a large degree of charge separation is also taking place, and this type of bond is known as polar covalent bonds. Polar covalent bonds. It is in this case, these polar covalents are more stable than pure ionic and pure covalent. And pure covalent bonds. Okay. Larger the degree of polarization, greater will be the stability of the compounds. Okay, larger the degree of polarization, greater the stability. Okay. Now, the extent of polarization depends upon two factors. Extent of polarization depends upon, first one, polarizing power of cation, and second one, polarisability of anion. Polarizing power of cation and polarisability of anion. Okay, so polarizing power of cation and polarisability of anion. As the polarization, the degree of polarization increases, the compound will be more stable. Okay, now there are certain rules regarding this polarization, degree of polarization. Let us discuss that one by one. Okay, first rule, cations with smaller size have higher polarizing power. Cations with smaller size have high polarizing power means they cause the polarization of electron cloud or electron charge cloud of an anion to a greater extent. Okay. Next, second one, anions with larger size have high polarizability. Anions with larger size have high polarizability. Okay. So, if the cations with high polarizing power and anions with high polarizability means the degree of polarization increases. Okay. Anions with larger size have high polarizability means the electron cloud can be deformed easily, or the electron charge cloud between the two ions increases. Third point is, for effective polarization, there should be high charge on the cation or high charge on the anion, or both. Okay. For effective polarization, there must be high charge on cation or anion. Okay. High charge on cation or anion, or both. Okay. Next, fourth point, cations with pseudo noble gas configuration, that is the outermost electron, that outermost shell contains 18 electrons, which is called as pseudo noble gas configuration, have high polarizing power than cation with noble gas configuration, noble gas electronic configuration. This means that this is due to the greater effective nuclear charge. Okay. So, fourth point, cations with pseudo electronic configuration, that is NS2, NP6, ND10. This is the configuration, that is 18 electron configuration in the outermost shell, have high polarizing power than noble gas. Noble gas configuration. Noble gas configuration is NS2, NP6. Because in this case, there will be the effective nuclear charge is high. So, they have high polarizing power. Okay. Pseudo noble gas electron configuration is having high polarizing power than noble gas electronic configuration. Okay. Examples, some of the examples are Zn2 plus, then Cu2 plus, Ag plus extra are examples. In such cases, the cations are having high polarizing power. So, what will happen? The covalent character, the polar covalent bond is have larger polarizing power, polarization. Okay, high degree of polarization in such cases. So, these are the four important points in the Fajan'S rule. Okay, so first one, cations with smaller size, anions with larger size, and if both of them are having high charge, and cation with pseudo noble gas electronic configuration. In all these cases, they have larger degree of polarization. So, the covalent character will be more in such cases, in such compounds. Okay.